Our next speaker is Carina Zona. She's a developer, she's an advocate and a certified sex educator. She is also the founder of Callback Woman, evangelist for Ruby Together, and co-organizer of We So Crafty. So let's welcome her on stage. Welcome her on stage. Thank you. Enjoy your talk.
Hi, as she said, my name is Carina C. Zona. You can find me pretty much everywhere on the internet as CC Zona, including on Twitter. This is a talk, it is a toolkit for empathetic coding. We'll be delving into some specific examples of uncritical programming and the painful results that can arise from doing things in ways that are completely benignly intended. And because of that, I want to start here with a content warning because I'm going to be delving into some examples that deal with some pretty intense topics. They're not the point of it, but they do come up. So some of the things that you'll be hearing about deal with grief, post-traumatic stress disorder, depression, miscarriage, infertility, sexual history, consent, stalking, racial profiling, and the Holocaust. If you would rather not be thinking about those things right now, it is fine to go and get another cup of coffee. I will not be at all unhappy with that. Go and enjoy it in the hall. And it will take about 10 minutes or so to even get into those, so you have some time to think about it. Algorithms impose consequences on people all the time. We're able to extract incredibly precise insights about an individual, but the question is, do we have a right to know what they don't consent to share, even when they're willingly consenting to share data that leads us there? And so that also raises the question, how do we mitigate against unintended consequences? When we talk about that word, algorithms, we're usually thinking in terms of patterns of instructions that are articulated in codes or math or formulas. And of course, the classic thing we associate with algorithms is Big O, right? Bubble sorts and its friends. But algorithms are far more expansive, really, than this. So generically, an algorithm is just any step-by-step set of operations for predictably arriving at an outcome. That's it. So in real life, we also have algorithms all the time. Things like patterns of instructions articulated in other ways, such as a recipe, or directions on a map, or crocheting a shawl. Deep learning is a field of machine learning, which is algorithms for fast, trainable, artificial neural networks. And deep learning is very hot right now for mining data. Essentially, it has been around in academia for a long time, since the 1980s at least. But it's only been some really recent breakthroughs, starting around 2012, 2013, that's really made it possible to start using deep learning in production at scale, rather than this sort of theoretical place that it's been in academia. Those recent advancements have been making it possible to suddenly extract considerably more sophisticated insights than anything we've been capable of doing before. And that's out of the vastness of even big data in production, in scale, at virtually real time. So here's the basic process. Inputs are just any collection of data, and they can be all sorts of things: words, images, sounds, objects, even abstract concepts. And then this training data doesn't even have to be labeled as such. It doesn't have to be picture of bird, picture of dog, picture of window. You just throw it pictures. So they don't have to be labeled or categorized in any way. So execution then is just running a series of functions repeatedly in a black box. And then finally, outputs are predictions of properties that are useful for drawing intuitions about similar future inputs. But remember, similar. The training data set must look a lot like the data set that it will be doing analysis on. And we'll get back to that later. So deep learning relies on artificial neural networks, just automated discovery of patterns within a training data set. And it applies those discoveries to draw intuitions about future data. For our industry, that means that it's presenting us with a breakthrough for dealing with big data, and it's really exciting. There's already so many companies that are adopting this and being able to do fantastic, interesting things. But notice what this means. Deep learning is premised on a black box. The neural network has drilled down to tens of thousands or even hundreds of thousands of incredibly subtle factors that it believes have predictive value, and we don't know what they are. So this stuff is driving major advances right now in all sorts of areas, including medicine, pharmaceuticals, emotion detection, all sorts of NLP stuff, face identification, voice-related things, fraud detection in transactions, sentiment analysis, even self-driving cars, including Tesla, are right now using deep learning to drive. Today we're going to be looking at some concrete examples that include ad targeting, behavioral prediction, recommendation systems, image classification, and face recognition. But first I want to really just show you a very whimsical one. This is Mar.io. It's an ANN that teaches itself how to play Super Mario World. It starts with absolutely no clue whatsoever. It doesn't know about its world. It doesn't know about movement. It doesn't know about rules and scores. It doesn't even have an understanding of gaming itself. It's just manipulating numbers and noticing that sometimes things happen. It's looking at the outputs and it's curious. So sometimes it notices that cumulatively changes produce interesting outcomes. And so it just keeps playing like this. It's learning movement and gameplay purely on its own via a self-training session in which it just engages in 24 hours of progressively more fine-grained experimentation that ultimately leads it to being able to identify patterns and use those patterns to predict insights, to play the game. And speaking of games, let's play one right now. It's called Data Mining Fail. It looks something like bingo, and it looks like this. Insightful algorithms are full of pitfalls. These are just a few. By looking at case studies, though, we can explore some of this board. So, are you ready? Are you ready? All right, I like to hear actual answers. Here are some user stories that we're going to be playing with. Target. Target is based in the US. It is a large department store chain where you can get stuff for every room in your house, plus your yard and your school and anything else you can possibly imagine, including groceries. It's a major retailer. Throughout the industry of retail, the second trimester of pregnancy is considered the holy grail because it's a moment in time where a person is ready to change every buying pattern they've made in their life. Every loyalty, every place that they go, what they buy, their brands, it's all up for grabs all over again. And because that person's starting a family, you're talking about being able to co-opt not just that person, but everyone else in that family too. So it's a powerful moment. If you can harness that buying power then, for a long time, you're going to have that customer. But how do you detect that a customer is in their second trimester? One day, the marketers at Target asked one of their programmers that question. How would you figure that out? And it's an interesting question. I mean, take a moment and kind of think like, well, if you couldn't ask them, what would you use? Well, it turns out that buying a lot of moisturizer is one of the key signs. I think there's some problems here. The question they asked is, if we wanted to figure out if a customer is pregnant, even if she didn't want us to know, can you do that? But notice, even if she didn't want us to know, it's an interesting challenge, but is it an ethical one? Several years ago, a man came into one of the stores and he was really mad. He was yelling. He said, "How dare you send flyers like this to my teenage daughter, full of stuff about pregnancy? Are you trying to tell her it's okay to have sex? Are you trying to get her pregnant? What is this?" And the manager, who's not in charge of these decisions, said, "I'm very sorry. You're absolutely right." The man went away. He came back the next day and he apologized to the manager. He said, "I had a talk with my daughter today. She is pregnant." So the algorithm was right, or at least it was correct. But it took something away from her. It took away her moment, her decision as to when to have that communication. That's something you don't want to start with someone who's angry. So Target got feedback like this, and they decided to change things a bit. So instead of having a flyer sent out to someone that's full of things that are clearly targeted at someone who's pregnant, they changed it to a flyer full of various completely random things that have absolutely nothing to do with pregnancy, and then the coupons that do. So most of it is cover for what they actually are targeting, what they actually want you to do. And their logic for this is, as long as a pregnant woman thinks that she hasn't been spied on, as long as we don't spook her, it works. Is this okay? It works. Shutterfly also did something similar. They were looking to target people who had recently had a baby and convince them to please send out lots of cards thanking people for their gifts and for their parties and all of their happy thoughts. So they sent out something like this to folks. It says, as a new parent, hey, you have this obligation to send out cards that we sell. Time to send those thank you notes about the birth of your child. They sent them to a whole lot of people. And some of those people had feedback for them too. Thanks, Shutterfly, for the congratulations on my new bundle of joy. I'm horribly infertile, but hey, I'm adopting a kitten, so. I lost a baby in November who would have been due this week. It was like hitting a wall all over again. Shutterfly responded that the intent of the email was to target customers who have recently had a baby. Well, yes, we got that. The point is that there's an error rate, and they didn't consider the effect of an error. Mark Zuckerberg became a father last year. He and his wife had announced the upcoming birth on Facebook, of course, and with great excitement. He also revealed then that they'd had a series of miscarriages before that. And he wrote, "You feel so hopeful when you learn you're going to have a child. You start imagining who they'll become, dreaming of hopes for their future. You start making plans, and then they're gone. It's a lonely experience." Facebook has a feature called Year in the Review. It's been implemented in various ways over the years. A couple of years ago, they decided to do it algorithmically. What they fail to take into account is that our lives are constantly changing. That something that was really exciting to talk about 6 months ago may be something that it's painful to talk about now. Not every memory stays the joyous one that it once was. Accidental algorithmic cruelty is the result of code that works in the overwhelming majority of cases, but doesn't take into account other use cases. Eric Meyer coined this term, and the reason he gets to name it is because he's one of the people it happened to. This is a picture of my daughter, who is dead. She died this year. The Year in Review ad keeps coming up in my feed, rotating through different fun and fabulous backgrounds, as if clicking her death, and there's no obvious way to stop it. Eric calls on us to increase awareness of and consideration for the failure modes, the edge cases, the worst case scenarios. And that's what I'm hoping to do here today, and I'm hoping that you'll carry it forward to others. So with that in mind, here is my first recommendation for all of us. Be humble. We cannot intuit inner state, emotions, private subjectivity. We're looking at external indicators as if they can tell us what's inside. Eric's blog post was in December of 2014, and it garnered a lot of attention, both within the industry and from broader media. So there should have been a lot of people who knew about this. How do you avoid blindsiding someone with unpleasant stuff annually? Facebook had to have done some introspecting about that, asking themselves this question of, what do we do next time? 3 months after Eric's experience, they introduced a new feature. It's similar to Year in Review, but it's at any time of the year. It's called On This Day, and it gives you reminders of various trivial things that may have happened on the same day in a previous year. So hey, 5 years ago today, you became Facebook friends with someone. 2 years ago, you went hiking. A year ago today, you had dim sum, yum. All right, so these are pretty simple cases, And they're really great about it. I mean, this is one of the things they learned, is to say, we care about you. We get it. Here's a memory for you from 3 years ago, and we think you're going to like it. Aww. Look at that. On this day, you posted a picture. Thanks, Facebook, for picking today to hit me with this dumb feature and remind me that my dog died 3 years ago. Sometimes Facebook's On This Day sends me memories from high school, and it's triggering. I did not enjoy high school, and I need to forget it. Facebook, you do not get to decide what parts of my life I should keep fresh in my mind and which parts I walk away from. Fuck off. We have to learn from mistakes. We have to learn from ours. We have to learn from others. We have to decide that harmful and harmless are not consequences that somehow balance each other out. Fitbit started off a little differently than the device we know today. Its website also was a little different. When it started out, it had a feature to track your sex life. And as you recall, Fitbit is a social service. So you're meant to be competing on things like how many steps you took, how many calories you ate, how many times you went running and for how long. Or in this case, compete on your sex life. The problem is that this defaulted to public. Here's an algorithm that decided or assumed that all data is equal. It's a default that doesn't work. We have to look at individual cases and make sure an algorithm isn't just sweeping up everything and pushing it out again. Most of us need internal DevOps tools. They may be for monitoring, performance tuning, business metrics, whatever. Uber's is called GodView. It tracks the cars around. You have a good sense of where things are in the city. But Uber didn't limit access to just administrators or restrict it just to operational use. Employees could freely identify any passenger by name and monitor that person's movement in the car, real time. Drivers used to have access to GodView too. I don't know why. Do you need to know where every other car is on the road and who's in it? Even a job applicant was welcome to access these private records. Meanwhile, managers felt free to abuse GodView for non-operational purposes, such as stalking celebrities' rides in real time and showing that off as party entertainment. Look at this cool thing we can do. It's an abuse of an algorithm. The algorithm's fine, it has use, but this is not what it should ever be touched for. The research group at dating site OkCupid also used to blog about things that they were learning from their aggregate trend data. They really loved looking at the data. And their blog focused on sharing various different insights about simple ways that an OkCupid user could use the dating site to date better. Uber also had a blog about its data, but it was a little different. The crucial difference is how Uber approached it. It wasn't about improving customers' experience of their service. If you look closely, it says, Uber can and does track your one-night stands. It's tracking your sex life as well. This is purely invading people's privacy, not for any operational reason, but purely for the sake of judging and shaming and laughing. This is not a predictable consequence for signing up for a rideshare service. Google AdWords. There was an interesting study a few years ago at Harvard in which the researcher herself had gone searching for her name, and she is black. Her name is LaTanya, and was surprised to see that the Google ads alongside the search results suggested that she has a criminal record. And so she did further study on this, and using two sets of names, one's highly associated with white people, one highly associated with black people, and separated by gender, just searching for those, combined with the last names of real academics. So what do you find? What they found was that a black identifying name was 25% more likely to result in an ad that implied that person had an arrest record. And before you think to yourself, well, maybe 25% of those people did, AdWords doesn't know anything about real life. AdWords works simply on clicks. It watches clicks and it tries to find the ad that people will most want to click on next. So what this is reflecting is our bias, our preconceptions, and repeating them, magnifying them, honing them. The real world isn't relevant to this, but it has real world effect. What we see here, our collective bias, is being both reflected to us and it's being reinforced to the next person. Data is generated by people. It isn't objective. It's constrained by our tunnel vision. It replicates our flaws. It echoes our preconceptions. Twitter. I can already hear the like, yeah. Joanne McDeal coined the term accidental algorithmic run-ins. And as you can tell, it's sort of a takeoff on Eric's term. And while she didn't give a formal definition, it can be roughly summarized as this: classifying people as similar, where careless prompts create scenarios that are harder for people to control and prepare for. Essentially, you're trapped by a recommendation system that's determined to show you someone similar that you'd actually probably want to avoid. It's a false positive that cannot easily be detected algorithmically. And sometimes the similarity factor can be pretty trivial, like this example from Last.fm. Just someone who, two people share a mixtape, but it was made by a person who one of them broke up with and one of them is with currently. And so the relationship between these people who don't know each other at all has something emotional baggage to it. Sometimes the factor connecting you to the person is intensely upsetting. If you've been stalked by a former coworker, Twitter may reinforce this connection, algorithmically boxing you into a past while you're trying to move on. Your affinity score, your harassers, will keep getting higher with every person who follows this person at Twitter's recommendation. So notice this. Just like AdWords, the algorithm doubles down on its false certainty with every action that third persons take. You're not the one who has any control over this, and people who don't know they have control over it are the ones who are in fact influencing it. Similarity algorithms can become, in effect, a proxy harasser, and many of those systems give no off switch for the user. Now we're going to look at some examples of face recognition. Flickr, Google Photos. So you recall when this first started coming out, we had them on phones, and they would give a cool square box like this. That's a face. It's become a lot more commonplace now, and we've seen plenty of really humorous mistakes like these along the way. This was iPhoto just a few years ago. It's a harmless mistake. It's a false positive, but it's one that's easy to chuckle at. Here's another. You may remember this site from about a year ago. It's Microsoft's HowOld.net, and it uses deep learning to make face recognition, to take it up to the next level, essentially. It's drawing those intuitions about age and gender, and it's assigning tags. And inevitably, it's going to make a few mistakes along the way, but on this site, that also doesn't seem like a big deal. They look pretty harmless. But there are false positives that are not funny, such as this next one, which is also last year. Flickr classified this as children's playground equipment. Dachau concentration camp, with its motto on the gate, "Work will set you free." Notice something else here. The gray tags on the side are the photographers, the ones he manually input. The white tags are Flickr's algorithmically added ones. This is a consequence of algorithmic hubris. It's treating human understanding as irrelevant to machine intuition. It's treating data as inherently neutral, as if something already known isn't worthwhile if it's something provided by a human. Flickr tagged this man as an animal. Originally, it also tagged him as an ape. This is a comparison that has a particularly ugly history. So let's be clear, this isn't about picking on any particular company or coder or methodology or even this particular technology. It's about a broader set of problems that befall us all. Here's Google Photos just a month after that last one. Google Photos, y'all fucked up. My friend's not a gorilla. So how does this happen? For one answer, you can go back to the 1950s in the US. In the 1950s, Kodak film was living in a very segregated America, and they were only interested in white consumers. And so they were making fine film emulsions that were focused on getting the most accurate detail possible from white skin. Black skin wasn't of interest for them. So for decades, their algorithm for developing film was based on finding the subtlest possible details in white skin. And so they passed out these cards called Shirley cards, and they were used every day by the photo technicians, to ensure that the film development process was always calibrated to find exactly the same colors, exactly the same detail. You never wanted to have variation. But notice here that black skin isn't even been tested. It's just not even relevant. The tools used to make film, the very science of it, are not racially neutral. And that means all of our development and processes have been responding to this legacy that is more than a half a century old. It contaminates our data, new as well as old, and that's a hard problem to overcome. Essentially, you have lossy data for people just because they have dark skin. It's tempting to just avoid thinking about it altogether. And so it continues on. A firm is a consumer lender specializing in a handful of products and firms rather than something where you would take a credit card and buy whatever you want any place. And it's also, of course, highly tech-based. The CEO is also one of the founders of PayPal. A firm makes an assessment of your creditworthiness based on just a few factors: your name, email, mobile number, birth date, and your government identification number. It also may ask you for additional information if necessary from other online sources, usually social profiles like GitHub. Okay, well, not everyone who buys stuff is on GitHub. It also may ask borrowers to share information, as well as it looks at other behavioral factors, like how long the person took to remember all the information that they gave. Not everyone processes information at the same rate. Does this mean that Stephen Hawking is a bad credit risk? Algorithms like these reinforce privilege. So remember, an algorithm is just that procedure for for reliably arriving at some outcome, whereas it's up to us to take into account what impact those outcomes lead to. And the outcome here is to reliably identify privileged people, mostly privileged programmers, and reliably exclude most people who don't share our abundance of privilege. Deep learning looks at such a deluge of data points, and it learns how to assign labels to them. But we have to hang on, because as humans we know that two identical data points can mean very different things. Understanding context is essential for drawing accurate conclusions about what individual data points mean. Without these, bias always runs rampant. If a machine is expected to be infallible, it cannot also be intelligent. That's Alan Turing. The immense power of machine intuition is irreplaceable, without a doubt, but it's not a replacement for human comprehension. A firm analyzes applicants' social media accounts, so do some other companies. One of them was Germany's largest credit rating agency. It considered evaluating applicants' Facebook relationships, which is odd because a personal friend is not necessarily the same as a Facebook friend. So now you're being judged based on relationships that may not even exist. But what about when that Facebook friend is in fact a genuine personal friend? Facebook recently defended a patent that pushes even further than Affirm's does. This patent is for making credit decisions about a person based on the unrelated credit history of their Facebook friends. So here's an algorithm with potential to deeply intrude on and even alter a person's real-life relationships simply to avoid being financially shamed and financially punished by an algorithm. It's important to maintain the discipline of not trying to explain too much, says Max Levchin, the chief executive of Affirm. Adding human assumptions, he says, could introduce bias into the data analysis. What? Dude, data is not objective. Data always has bias. It's inherent at minimum from how it was collected and interpreted. And then every flaw and assumption in that first data training set and the original functions and who made assumptions about them, all these things along the way are having unrecognized influence on the algorithms and the outcomes they generate. Affirm says that its algorithm assesses 70,000 personal qualities, whatever that means, but 70,000 factors. How many of those have potential for some sort of discriminatory outcome? How would anyone know? It's not like someone can tell you what criteria led to a decision. Only the black box knows. Rationales from the algorithm can only be seen from inside the black box. So I took a photo for you of the inside of a really, really black box. Making lending decisions inside a black box is not a radical new business model. It's a regression. What it's disrupting is fairness, accountability, and oversight. Algorithms always have some kind of underlying assumption about meaning, about accuracy, about the world in which the data was generated, about how code should assign meaning to it. Underlying assumptions influence outcomes and consequences being generated every time. Our industry is in an arms race right now, a deep learning arms race, and it will continue to accelerate and move on. Major players are already rolling out projects that have made big bets on this technology and its opaque intuitions. And for the moment, yes, quality varies, but remember, this moves fast. It's all about iteratively drawing predictive intuitions at extremely fine-grained levels, which means every time they're growing both more precise in correctness and more damaging in wrongness. And that's the dilemma for us. And the thing is, we do care. We care about getting this stuff right. We want to be empathetic coders. So how do we flip that paradigm? How do we go about solving some of this? Here are some starting points. Consider decisions' potential impacts on others. How might a false positive affect someone, such as those Shutterfly customers or those Twitter users? How might a false negative affect someone, for instance, being denied a loan? How many other ways can an algorithm's intuition be superficially correct and yet deeply wrong about human context, like at Dachau? Or the reminder of Eric Meyer's daughter. We need to project the likelihood of consequences to others. We need to minimize negative consequences to others. And I'm just going to keep on saying to others, because it's really easy to look at these things and say, it's really cool, we're making something really great, it's moving the world forward. We have to keep on thinking not about what's really useful and neat and not likely to harm us, and constantly be thinking about users and those beyond them. We can adopt the same motto that the medical field has: first, do no harm. And we need to be really honest and trustworthy, not just because, it's the right thing to do, but also because it's business necessity. We're going to make big mistakes on this stuff, just like these other folks did. And we need to be able to say when the time comes, we're sorry, this was an honest mistake, we're fixing it immediately, and we will make sure it never happens again. If we haven't earned that trust beforehand, we could really lose big. It's important to have that foundation of trust already there. And that's why it's also important to always build in recourse for someone to easily correct a conclusion that was wrong. We need to provide others with full disclosure of limitations, and we need to call attention to signs of risk of harm to others, because there's always limitations, right? An algorithm is targeting a particular problem, a particular context for that problem, applying assumptions about it, and there's an acceptance of a certain amount of errors or flaws or imprecision. We're never waiting until it's 1,000% always correct every time in all circumstances. It just has to apply to solving a particular problem at a particular moment in time. This is a chicken breast. The picture is excerpted from a video that Emily Gorsensky took of an activity tracker while it was detecting a steady pulse of 120 beats per minute from the chicken, which I think is pretty good. The algorithms driving consumer activity trackers are not precise or consistent. They have value, but users do need to hear from us that they're not intended to be used for some sort of exact purpose. And we also need to somehow make sure that that's known to the wider public, because recently an activity tracker was used to convict a person. The data from it said that she wasn't at the place that she said she was, and it didn't say that her heart rate was consistent with what they believed the tracker was showing. And so the kind of inaccuracy that we're seeing on Emily's chicken breast can be used to devastating effect unless it's very clearly communicated what the limitations of this technology is. It's really more for entertainment value. It's for having some sort of baseline to compare your own day-to-day, not to say objectively, this is reality. We need to be visionaries about creating more ways to counteract biased data, biased analyses, biased impacts, and finally, we need to anticipate diverse ways to screw up, because as long as the teams who are charged with defining data collection, use, and analysis are less diverse than the intended user base, we will keep failing them. We must have decision-making authority in the hands of highly diverse teams. Culture fit is the antithesis of diversity. Superficial variations are allowed to exist, that's all. Their unique perspective is suppressed because the point of culturethink inherently is to avoid disruption of groupthink. We're all going to think basically the same thing and agree it's really good. Unidimensional variety is also not diversity. Diversity is wildly varied on as many dimensions as possible. It has different origins, different ages, different assumptions, different experiences, where there's no majority clearly to see it all. Audit outcomes constantly. In housing and other forms of discrimination, auditing is used to find essentially what comes out of the black box. So while you can't stand over a landlord's shoulder and ask them, are you biased? Are you biased? What you can do is send in two different people with the exact same application and see whether they both get selected. This has also been done in all sorts of research studies, things like resumes as well, job huntings, and every time it turns out that yes, bias can be detected reliably this way. So this is an opportunity. Make sure you're looking at the outputs and make sure that they line up with what your expectations are. Make sure they're lining up with highly unlikely expectations. Does it still make sense? Because again, all we've got is that really, really black box. So here you have an example. Something where you might have a fellowship, a job, a mortgage, and you only have to change just one attribute, whatever it is, and just send those application data into the black box and see what's its outcome. Are they fair? Are they equal? Are they predictable? You know really obvious differences to audit for. Anything that's protected by laws at a minimum, that of course should be there, but what about subtler cues? Two identical applications for something, why is it not working? Okay, sorry. What meaning is that system then implicitly ascribing? So for instance, a difference of a family name or of personal apparel, face recognition is in there. Is it judging less of a face as somehow less data or as different data altogether? We could say no harm intended, but that really is not sufficient, because as we've seen, unintended, totally unconscious bias is surrounding us. So the rule has to be that unless you can draw a complete decision tree for every possible combination of inputs and every possible output for them, then you need to audit outcomes. All right, so what does that entail in practical terms? We looked at that Google AdWords study from Harvard. That's one example of outcome auditing. Here's another one. Carnegie Mellon made an ad called Ad Fisher, and it generates pristine Google user histories that are carefully chosen trails across the web in such a way that an ad targeting network will infer certain interests or activities. That sounds very dry, but I think we know what this is really doing here. Google responds with just job ads. It's given templates, it fills them in. It ended up showing high pay jobs to 600% more of the men compared to women. So the job opportunities are being, again, changed in the same kind of way that they were for black and white people. Another thing we could do is crowdsource all the things. These case studies are highlighting for us that mining social data is full of pitfalls, many of which cannot be solved by technology alone. So don't go it alone. Bring crowds in, because, this is important, artificial neural networks are only crude approximations of the human brain's ability to constantly develop sophisticated algorithms. We're the real geniuses in the equation. What we ask of a machine is consistency. Yammer has been using this for years. This is from a talk given in 2012 by Heather Rivers at Yammer, and they crowdsource internationalization. So you can choose at any time to start translating for the site, and you can choose a variety of languages, and as well, then once you do put in a translation, others essentially fact-check your work. So by upvoting and downvoting, you're getting a more and more refined set of data without having to do any work at all. The users are doing it for you. Google has similar problems. It's getting pretty good at being able to interpret almost every language except one brand of English. It can't figure out what the heck Scottish people are saying. And so they've outsourced this problem to Mechanical Turk, which is just humans. It's just asking humans a whole lot. What are these people saying? What are these people saying? What are these people saying? So they're paying to substitute for machines and substitute with people. They also have a crowdsource app, which is kind of fun to look at. I recommend downloading it, if nothing else, for some entertainment value. It gave the chance to, again, sort of check others' work. It identified the translation in German to English. Deutsche is either translated to America, Canada, or South Africa, depending on the personal user who translated it. So we also need to make instructions for the crowd pretty clear, because it's really noticeable that some users are mistakenly treating it as something else, like a thesaurus. So instead of giving a direct translation, they'll give you, oh, it means this or that. And so that's also essentially data noise that you need somebody else to catch and correct. Some users also treat it as, I'm talking to a programmer. And so they would give responses like, I don't know. So we need to make sure that when we're turning to the crowd, that we still have an algorithm for talking to them about what it is we want. And so we always need to iterate, get that feedback, not just the original data, but getting it more refined feedback on that over and over again, because there are attempts to sabotage, there are just innocent errors. All of them need to be caught. We also need to cultivate informed consent. That's asking for permission with the default being no, where we focus on the many who eagerly share themselves and are enthusiastic about giving consent to be known more and served better. Facebook's been making adjustments along the way. On this day, and you're in review, and now ask questions like, do you want to use this feature? Do you want to edit its choices? Which people don't you want to be reminded of? Which dates? Which posts? That sounds pretty good. It's effort, it's well-intended, it still misses the point because you have to do things like remember who you don't want to remember. You have to make a list of them. The newer, gentler features are all premised on list things you don't want to think about. Just think up a list of everything you don't ever want to have to think about. Dig up what hurts you to fend off the algorithm. So what they're doing is still fundamentally opt out, not opt in. It is still putting the burden on the user to solve a problem created by the algorithm. Why not just let Twitter users select the people that they recommend that others follow? We already have this. It's called Follow Friday, #FF. This data already exists. Why are you trying to extrapolate it from a much poorer system? It's cheaper, it's faster, and it's more accurate. Or you could just have a checkbox. That pregnant person isn't the only one who might have a stake in the pregnancy and in buying a whole lot of stuff for it. Friends and family members might also really love to have all those coupons, and those are also people that you could be cultivating right now. Opt-in is not necessarily a bad thing. It can be more profitable. And that's why we also need to commit to data transparency and algorithmic transparency. And I know this is the hardest conversation to have internally because too many companies think keeping everything proprietary is the secret sauce, the way we win. But I also really remember that it wasn't that long ago that we had to fight for legitimacy of open source in our professional toolkit at all. We pushed back, and we were right to. We're professionals. We know that transparency is crucial for drawing insights that are genuine and useful. So we have to start the conversations, please. Argue for increasing transparency because it's for the sake of a better product. Cleaner features, fewer bugs, stronger tests, happier users, public trust, more money. Because we build stuff that matters. Amy Hoy is harsh, but she's right. If your product has to do with something that deeply affects people, either care or quit, or go live in a cave and don't hurt other people. It's so easy to unthinkingly build an app full of data mining fail. Building differently requires awareness, critical thinking, and deciding as a team to take a stance, to say, hey, listen, here's the deal. We do not build things here without first understanding consequences to others. This is just our process. This is a good process. We're hired for more than just to do code. We're not code monkeys. We're hired as professionals to apply our expertise and judgment about how to solve problems. Our role is fundamentally to be opinionated about how to make code serve a problem well. When we're asked to write code that presumes to intuit people's internal life and act on those assumptions, as professionals, we have to be people's proxies, be their advocates, stand up for them, say no on their behalf to using their data in ways that they have not enthusiastically and knowingly consented to. Say no to uncritically reproducing systems that were biased to begin with. Say no to writing code that imposes unauthorized consequences onto their lives. In short, refuse to play along.
Thank you, Carina. This was eye-opening.